Question 1. What is the primary objective of computer vision within artificial intelligence? Option A. To process and compress digital images for storage efficiency. Option B. To enable computers to see, interpret, and understand the visual world. Option C. To generate new, original images based on textual descriptions. Option D. To convert spoken language into written text from video inputs. The correct answer is, quote, to enable computers to see, interpret, and understand the visual world. Here's the explanation. The overview states, its primary objective is to enable machines to derive meaningful information from digital images, videos, and other visual inputs, and then to take actions or make recommendations based on that understanding. Question 2. Which computer vision task is defined as locating specific objects within an image and drawing bounding boxes around them to indicate their position and size? Option A. Image segmentation. Option B. Object recognition/classification. Option C. Object detection. Option D. Scene understanding. The correct answer is object detection. Here's the explanation. The Key Features/Components section defines object detection as locating specific objects within an image and drawing bounding boxes around them to indicate their position and size, often combined with classification. Question 3. In modern computer vision, what is the foundational deep learning architecture primarily responsible for learning complex visual patterns directly from raw pixel data? Option A. Recurrent neural network. RNN. Option B. Generative adversarial network. GAN. Option C. Convolutional neural network. CNN. Option D. Support vector machine. SVM. The correct answer is convolutional neural network. CNN. Here's the explanation. The study material highlights that convolutional neural networks, CNNs, are the foundational architecture for most modern computer vision tasks, excelling at learning complex visual patterns directly from raw pixel data. Question 4. A retail company wants to analyze images of product shelves in their stores to automatically detect specific products, count their stock levels, and identify any misplaced items. Which Azure AI vision feature is best suited for this task? Option A. Optical character recognition. OCR. Option B. Content moderation. Option C. Image analysis with object detection. Option D. Face detection and analysis. The correct answer is image analysis with object detection. Here's the explanation. Image analysis with object detection is precisely designed for identifying and localizing common objects within an image using bounding boxes. This aligns perfectly with the need to detect specific products and identify misplaced items on shelves. OCR is for text, content moderation for inappropriate content, and face detection for human faces. Question 5. A company needs to extract structured data like invoice numbers, dates, and line item details from scanned invoice images. While Azure AI Vision's Read API can extract all text, which other Azure AI service is specifically optimized for understanding the layout and relationships within such structured documents to extract key value pairs? Option A. Azure AI Video Indexer. Option B. Azure AI Document Intelligence. Option C. Azure AI Face. Option D. Azure AI Speech. The correct answer is Azure AI Document Intelligence. Here's the explanation. Azure AI Document Intelligence, formerly Form Recognizer, is specifically designed for structured and semi-structured documents like invoices, receipts, and forms. It excels at understanding the layout and relationships between text fields, extracting key value pairs, and table data, going beyond just raw text extraction offered by Vision's Read API. The other options are for video, faces, and speech respectively. Question 6. A manufacturing plant needs to automatically identify defects on specific components on their assembly line. The defects are highly specialized and unique to their product. Which Azure AI vision capability would allow them to train a model to recognize these specific defects without writing complex machine learning code? Option A. Image analysis. Option B. Content moderation. Option C. Smart cropping. Option D. Custom vision. The correct answer is custom vision. Here's the explanation. Custom vision is a specialized tool within Azure AI Vision that enables developers to build, deploy, and improve their own custom image classification and object detection models. It allows users to train models with their own labeled data to recognize specific objects or classify images relevant to their unique domain, such as specialized product defects, without requiring deep machine learning expertise. Question 7. What is the fundamental difference between image classification and object detection? Option A. Image classification identifies multiple objects and their locations, while object detection assigns a single label to the entire image. Option B. Image classification provides a single label for the dominant content of the entire image, while object detection identifies multiple objects, assigns labels, and provides bounding box coordinates for each. Option C. Image classification relies on unsupervised learning, while object detection uses supervised learning. Option D. Image classification is a manual process, while object detection is fully automated. The correct answer is image classification provides a single label for the dominant content of the entire image, while object detection identifies multiple objects, assigns labels, and provides bounding box coordinates for each. Here's the explanation. The overview and comparison/related concepts sections explicitly state that image classification assigns a single label to an entire image, whereas object detection identifies multiple objects, assigns labels, and provides bounding box coordinates for their locations. Question 8. In the context of convolutional neural networks, CNNs, for image classification, what is the primary purpose of a pooling layer? Option A. To apply a set of learnable filters to detect specific features like edges and textures. Option B. To introduce nonlinearity into the network, allowing it to learn complex patterns. Option C. To reduce the spatial dimensions of feature maps, thereby reducing computational complexity and providing translation invariance. Option D. To convert raw scores into a probability distribution over predefined classes using a softmax function. The correct answer is to reduce the spatial dimensions of feature maps, thereby reducing computational complexity and providing translation invariance. Here's the explanation. The How It Works section details that pooling layers, e.g. max pooling, reduce the spatial dimensions of feature maps, which reduces computational complexity and provides translation invariance. Question 9. A developer needs to train a custom image classification model for a very specific set of product defects, but only has a relatively small dataset. Which technique is most recommended to achieve good performance with limited data and computational resources, according to the study material? Option A. Training a CNN from scratch with a very deep architecture. Option B. Manually engineering features like SIFT or HOG for a traditional machine learning model. Option C. Utilizing transfer learning by fine-tuning a model pre-trained on a large, generic dataset. Option D. Relying solely on data augmentation without any pre-trained models. The correct answer is utilizing transfer learning by fine-tuning a model pre-trained on a large, generic dataset. Here's the explanation. The key features/components and exam tips Sections highlight transfer learning as a common and highly effective technique for smaller custom datasets, as it significantly reduces training time and data requirements by leveraging pre-trained models. Thanks for watching. Please subscribe to my channel.